Okay, so here's my portfolium for chapter 12. So chapter 12 was sort of just a nice introduction to functions of two variables with x, y, and z. And I think the most important part of this unit was just learning about how important concepts that we've already gone over many times in two space could be translated into three space and sort of the changes that we would have to do. So the first problem I included was the distance formula. And the distance formula in three space is almost exactly the same as it is in two space. All we have to do is add on the z component, z1 minus z2 squared, and we can calculate the distance in the same way that we would in two space. So the next problem I looked at was linear functions, because they're sort of the most common and simple functions that we go over in two space. And we can see that it's almost exactly the same. It takes on the same form in three space with just two slopes and an intercept. And we can calculate for those slopes and intercepts after getting some points. We can do it in the same way that we would in two space, with just plugging in the points and solving for the unknowns. So another important thing that we have to know for calculus is limits. And in three space, something I thought was pretty interesting is that we can find if a limit exists by simplifying it. So all we have to do in this, for example, in this situation is, since we're looking for the limit as x and y approach 0, 0, then we can substitute y equals 2x or y equals 3x in, because they also approach 0 as x approaches 0. And then what we can do there is solve for the limits, and if they match, then the limit exists, but in this case they don't match, so we know that the limit doesn't exist as x and y approach 0, 0. So something else that I thought was pretty important for two space was being able to match the formula with a graph, and we can do that by using strategies such as end behavior or asymptotes, or looking at the degree of the function. So for this one, when we look at number 4, we can see that it's a plane, so we know that the equation is linear, so then we can find the linear equation in this set. Okay, something else that we learned that was sort of new for me was contour diagrams, and it's a way of simplifying three space, so we can project functions from three space into two space by just making it like a sliced, and we can represent those functions with contour diagrams, and being able to identify which contour diagrams match which graph was also pretty helpful. And we can use similar clues such as the spacing and the shape of the curves to match them to the graph. So the next 3 problems I included all have to do with real life situations, because I think that in two space we definitely emphasized a lot of being able to interpret the situations from a function or a graph into what it actually meant. So something new in three space that we had to look at was, if we hold a variable constant, if the other variable is increasing or decreasing of each other. And another real life situation I included was the CARS project. So this one is a multi-regression, and we used a linear model. So we can see just the two slopes and the intercept, and being able to interpret these intercepts and slopes was pretty helpful. And I think it's something that we had to do in two space, and now we're learning how to do it in three space. So lastly, there is a real life situation of 4 variables, which what we're doing is projecting it into a level surface, which makes it a lot easier to visualize and interpret. And we can see the types of problems we get with interpretation, with seeing they're increasing of each other and what that means in real life, and just being able to interpret if we plug in the numbers to see what the situation actually means. So in conclusion, chapter 12 was a nice introduction to three space, and we got to learn how a lot of common concepts in two space connected and changed when we put them into three space.